For the week. Today I'm going to lecture on reviewing some arithmetic sequences, which we talked about before the CA, and then pushing into geometric sequences. Tomorrow we'll have some time to work. Wednesday is a quiz, open notes on arithmetic sequences. Thursday I'll be lecturing on geometric sequences, and finally Friday will be another work day. Is there any questions on schedule for the week? The other thing I want to say, I say at the beginning of every 6 weeks, is like, if you spend 30 minutes a night and then an hour on the weekends, I think you will achieve a B or higher grade, virtually guaranteed. 30 minutes a night, an hour on weekends, use the work days effectively, reach out for questions, B or higher, almost guaranteed. Try that consistently, and I think you'll be surprised at the results. The other piece is, this says it's due on March 4th by 1:05, and the reason for that is juniors have leadership conference that day, so we won't have class, so you guys can just pop in my box. Seniors, you guys will have the class period to continue working on that. Any questions on logistics? Okay, seeing none, let's jump right in. I'm on problem number 3 on level 1. So level 1, number 3. So level 1, number 3 says A5 equals 18, A12 equals 32, and they want us to find A1, they want us to find the common difference, and A20. So when I start this problem, I'm noticing right away that this is an arithmetic sequence. So I'm noticing right away we have an arithmetic sequence. Because we have an arithmetic sequence, we know that the nth term formula, as you all recall, is an equals a1 plus n minus 1 times the common difference. Now, when I look at this problem, I notice a5, a6, a7, a8. So remember, this is just a way to visualize what is happening here. We know A5 is 18 and A12 is 32. So when I look at this, there have been 7 jumps. 1, 2, 3, 4, 5, 6, 7. So 7 jumps. It's not a coincidence that 12 minus 5 is 7, right? That's why we have 7 jumps. So for those who don't necessarily want to draw the picture, we're good with 7 jumps. And every jump, all I'm doing is adding the common difference. So I'm basically adding the common difference 1, 2, 3, 4, 5, 6, 7 times. So 7 times the common difference equals how far did I travel? I traveled from 18 to 32. 32 minus 18. That's the total distance I traveled from where I ended minus where I started. So I traveled 7 times the common difference. 7 equals 14. Common difference is 2. Now, if we know the common difference equals 2, I can then find A1 and A20. We know that any term is given by this formula. So I could specify this formula a little bit more and say that A5 is equal to A1 plus n minus 1 times 2. We know A5 is 18. So 18 equals A1 plus 5 minus 1 times the common difference. We already know what the common difference is. We just found it. The common difference is 2 plus u. So 18 equals A1 plus 4 times 2. Solving for A1, I have this. Is that a question? No.
I was going to say, you can just subtract 2 backwards.
You can, right? That's absolutely right. You can keep subtract 2 backwards. The only risk with that is like, what if they'd given us like A98 and A10? Yeah, but in this case, yeah, absolutely. So now we have A1, and the final piece they wanted was A20. A20 equals A1 plus n minus 1 times d. Because remember, this formula holds for any term in any term in an arithmetic sequence. So A20, A1 is 10, we just found that. N is, in this case, 20, because we want the 20th term. And the common difference is 2, we already found that. So A20 equals 10 plus 19 times 2. We know that 19 times 2 is 38. 38 plus 10 is 48. Questions? All right. Let's move to number 5. So level 2, number 5. In level 2, number 5, it says rewrite the following in sigma notation. So let's first copy down the sequence that they've given us. They want us to rewrite this in sigma notation. If you recall from before the common assessment, we talked about sigma notation. And we said sigma notation has an index, which you could pick any letter for as long as you maintained that letter in the nth term expression. It had a lower bound, upper bound, and then right here was the expression that could generate any term. As I look back at the sequence they've given me, I notice that we have a common difference of -4, because every time I am adding -4. Remember, the common difference is whatever you're adding to one term to get the next one. Given that we know the common difference, we can now write the general formula for any term of this arithmetic sequence. We want to write the general term for this. Now, in the past, I had often left it like this. Except here the instructions say, ensure the nth term is as simplified as possible. So let me simplify a little bit more, given that that's what the directions say. When we're simplifying, all we're really doing is algebra. And now this will go right here. One more time, Frey?
And the -4 and the beginning?
Yeah, so you could have written -4n plus 16.
Yeah.
That's fine. Now, we're starting with term 1. The question is, what term number do we end with? Many people are tempted to put -48 here. That's incorrect for 2 reasons. One, you can't have a negative term number. And the second one is, -48 is the value of this term. It is not the term number. This is term 1, not term 12. 12 is the value. But this is term number 1, term number 2, term number 3, term number 4, and so on and so on. So we need to find what term number is -48. Of course, the way to do this is to plug in -48 into this equation right here and solve for n. Since we're solving for n, you all remember how to do this from algebra. These two numbers don't have to be the same, it's purely coincidental. Questions on this one before we go forward? Any questions? If you subtract negative 16 on both sides? Does that work? Okay, so you wanted to add this here? Okay. Go ahead, Edgar.
What about n equals 1? I remember from last time you said n doesn't always...
I mean, yeah, it doesn't always have to, and in fact, in the next few days, we'll see some examples where n doesn't equal 1. But when you're writing a sequence in sigma notation, it's a safe assumption that n is starting at 1.
Wait, so if it's arithmetic, is it always equal to?
Yeah, I mean, I think it's like a safe assumption for both arithmetic and actually geometric. We'll see some exceptions to that rule on Thursday. Go ahead, Anthony. No, you are not supposed to write that. If you wrote n equals 16, I probably wouldn't take off. It just looks a little bit clunky, and no one else would do it. So it's just kind of imprecise mathematical notation. Good question. Now let's go to number 8. On number 8, they've given us the sigma in this case. And in this case, they chose to use the letter J. Remember, you can actually use any letter you want as long as these, remember we call this the index as a math term, as long as the index is the same below the sigma and to the right of the sigma. And when I look at this, it might be helpful for some of you if we translate what this is saying into actual English. So what this means in English is the following. Find the sum of terms 1 through term 55. Term 1 through term 55. Determined by the nth term expression 3j minus 1. So it's find the sum of terms 1 through term 55 determined by this expression. Excuse me. When I look at this, I don't know whether this is an arithmetic or a geometric sequence. However, I can begin plugging in values for j and determine whether I see a pattern or not. So let's find out. If j equals 1, so there's my first term. What happened? Here's my second term. And there's the third term. As you look at this, many of you begin to see that we're developing a sequence that looks like the following. When you see this, I hope you realize what kind of sequence this is right away. We have a common difference of 3. Therefore, we have an arithmetic sequence.